Welcome to today's explainer. Look, if you've been feeling like your AI-assisted dev workflow just hit a bit of a brick wall lately, you are exactly in the right place. Today, we're going to completely unpack a profound industry shift. We are moving away from manual prompting, which frankly is quickly becoming a thing of the past, and stepping into the world of automated loop engineering. To get you there safely, we're going to explore a comprehensive 14-step roadmap. Right off the bat, consider this massive metric, 8x. According to recent reports, Anthropic engineers are merging 8 times more code per day than they did back in 2024. Now, sure, some debate if this slightly overstates the pure productivity gains, but there is absolutely no denying that this sets the ultimate high-stakes benchmark for developer velocity. And here's the thing, this isn't happening because they magically type faster. It's happening because they fundamentally changed how they interact with AI. They aren't just giving instructions anymore, they're designing autonomous systems that do the heavy lifting for them. So, let's dive into this evolutionary roadmap. Our agenda today covers 1. The end of manual prompting, 2. The loop design cycle, 3. Maker versus checker agents, 4. Managing state and agent memory, 5. Avoiding the Wiggum failure mode, and finally, 6. Safely building automated loops. Section 1. The end of manual prompting.
The paradigm shift here is honestly pretty stark. If you think about the old way where you're still typing out single prompts, sitting around waiting for a response, manually reading the diffs, and then typing another prompt just to fix the errors, well, you are the bottleneck. You're completely missing out on the new way, which is loop engineering. The industry gap between just building a simple prompt response agent and designing a system that self-improves through automated scheduling and continuous verification is literally worth 6 figures in value. It's all about creating systems that independently identify, execute, and most importantly, verify their own work.
Section 2. The loop design cycle. So how do we actually create that independence? The crucial point is that high-quality production AI systems no longer rely on single model calls. Doing that is basically a recipe for hallucinations and fragile code. Instead, they utilize this continuous 4-step cycle: generate, evaluate, learn, and improve. It's a fundamental setup where the system acts, observes the outcome, like checking if a test passed or failed, learns from that specific failure by saving the context, and then adjusts its approach on the very next iteration. This cycle is exactly what allows your loops to self-correct and adapt to highly dynamic coding environments without you having to hold their hand. To actually trigger these cycles out in the wild, developers are turning to specific primitives within their tools. For example, using Claude Code, you can leverage commands like /loop to establish a session-scoped cadence, meaning the system runs on a reliable set schedule. But even more powerfully, you can use the /goal command. This tells the agent to continuously run, iterate, and try entirely new approaches until strict objective success conditions are met. We're talking things like a green CI build or a passing linter. This effectively shifts your job from actively prompting the AI to simply defining the finish line.
Section 3. Maker versus checker agents.
Now, here's the billion-dollar question. How do we ensure these loops actually produce quality work rather than just generating absolute garbage at scale? We need an architectural split. You have a maker agent that actually writes the code and a completely separate checker agent that strictly evaluates it against a rubric. This is absolutely vital because it solves what we call self-evaluation bias. Think about it. If you let a single model act as both the writer and the grader, it's almost always going to be way too lenient on itself. It'll confidently tell you the code is perfect when it's secretly broken. By decoupling the worker from the judge and forcing the maker to defend its work to an adversarial checker, you dramatically increase the reliability of your outputs.
Section 4. Managing state and agent memory.
Tracking progress is crucial, right? A brilliant checker agent is totally useless if the system forgets what it was doing 5 minutes ago. To build a persistent memory spine, you have to write an agent state down. If you're working solo or on a small team, keeping a simple STATE.md file right in your repository is fantastic. It's simple, it's diff-readable, it just works. But when you scale up to production loops with fleets of agents running in parallel Git work trees, you really need to upgrade. Hooking your loops into external issue trackers like Linear or GitHub Issues allows for team-wide visibility, and it lets your agents query their state across entirely different repositories.
But actually, having a state file isn't enough if your agent slowly forgets the big picture. Have you ever played the game Telephone? That is exactly what happens to an agent's context during a long loop. It's called lossy summarization. To prevent this kind of goal drift during long sessions, your agent must continuously reference a high-level spec file. Think a standing vision.md or agents.md file. By forcing the agent to reread this foundational document on every single run, you ensure it never loses sight of its ultimate objective, no matter how many iterations it takes to get there.
Section 5. Avoiding the Wiggum failure mode. Building these systems isn't all sunshine and 8x productivity metrics. There are massive risks and expensive pitfalls. The most crucial point is avoiding this visceral and honestly kind of hilarious failure mode, affectionately known in the industry as the Ralph Wiggum failure mode. This happens when your agent just decides it's finished and confidently exits the loop, but the job is only half done. Why does this happen? Well, usually it's due to soft completion conditions, like if you ask the agent, does this look right, instead of using an objective verifier like an automated test suite. When an agent Ralph Wiggums on you, it has successfully burned through your token budget while giving you absolutely zero return on investment.
And speaking of return on investment, how do you know if your loop is actually a net positive? Look at this threshold, 50%. This represents your cost per accepted change. If you've got an automated loop running, but a human is rejecting and rewriting the output so often that your accept rate falls below 50%, your loop is failing. At that point, ambitious loops can burn 5 to 10 times more tokens than you originally expected. You're actually losing efficiency just to the manual human review required to clean up the agent's mess.
Section 6. Safely building automated loops. So how do we prevent those massive token burns and security nightmares? We build the system incrementally. You absolutely cannot just jump straight to step 4. First, you have to perfect a manual run to prove the AI can actually do the task. Second, you turn that context into a skill file so the agent doesn't start from zero the next time around. Third, you wrap that skill in a loop with an objective verification gate, like a unit test. Only after you've established manual reliability, context storage, and strict gates should you even think about scheduling it for full automation. And to maintain absolute control over these new automated systems, you must implement essential safety gates. Set hard budget and time ceilings so a confused agent doesn't just run up a massive API bill over the weekend. Use step cops and circuit breakers that automatically halt the system after consecutive failures. Always mandate human review for irreversible actions, like merging to the main branch or deploying to production. And finally, keep an eye out for comprehension debt. That's that dangerous scenario where your automated loops are writing and shipping code way faster than you or your team can actually read and understand it. As we wrap up this explainer on loop engineering, I want to leave you with a vital question to ask yourself when you log on tomorrow morning. Are your current AI workflows building compounding assets that get smarter and more autonomous every single day? Or are you just burning daily tokens, manually typing prompts into the void? The roadmap is right here. It's time to step up and become a loop designer. Thanks for joining me today, and keep building.